Somewhere right now, a viral post is telling millions of people that gravity is going to switch off for a few seconds on August 12th, that the planets are going to line up in a perfect row and cancel out the pull of the Earth. It has been shared hundreds of thousands of times, and it is completely 100% not true. But here is the strange part. The date in that post is real. August 12th, 2026. Actually is one of the most extraordinary days in the sky in living memory. You just will not float off the ground while it happens. In less than 24 hours, 6 planets will rise together before sunrise. The moon will swallow the sun whole over a narrow strip of Europe for the first time since 1999. And once the sky goes dark, one of the best meteor showers of the last 2 decades will light it up from horizon to horizon. 3 separate cosmic events stacked into a single day, on a scale that will not happen again for a very long time. So let's actually break down what is real, what is hype, and exactly when and where you need to look, because getting this wrong by even a few minutes means missing the whole thing. Let's start with why this date exists at all, because it is not a coincidence dreamed up by an astrologer. It is orbital mechanics lining up 3 completely unrelated clocks at the exact same moment. And before we go further, let's actually deal with that gravity claim properly, because it's worth understanding exactly why it's wrong, not just that it's wrong. The idea seems to have started from a real, boring scientific fact that got twisted into something dramatic online. Back in 1974, a British astronomer wrote a book that jokingly suggested a rare planetary alignment could cause tiny, barely measurable effects on Earth. It was mostly a thought experiment. Somewhere over the following decades, on the internet, that harmless thought experiment mutated into headlines claiming you would briefly feel weightless. Every time a handful of planets line up in roughly the same direction, this claim resurfaces, and every single time, it fails to happen, because it was never physically possible in the first place. Jupiter is the most massive planet in our solar system, and even Jupiter's gravitational pull on your body, from its average distance, is thousands of times weaker than the pull of the Earth beneath your feet. Stack 5 more planets on top of that and the combined effect still doesn't come close to something you could feel, let alone something that could cancel gravity. So keep that in mind anytime one of these viral posts resurfaces, because it will, probably during the very next planetary alignment after this one. The moon orbits the Earth roughly once a month. The Earth orbits the sun once a year, and Earth passes through a stream of comet dust called the Perseids every August, like clockwork, because that is when our orbit crosses the debris trail left behind by a comet called Swift-Tuttle. None of these 3 cycles know about each other. They just happen to intersect on August 12, 2026. That is the entire secret behind the hype. Nothing supernatural, just really good timing. Now, why is this eclipse specifically such a huge deal? Because the last time a total solar eclipse crossed mainland Western Europe was 1999. If you are under 30, there is a real chance you have never seen a total eclipse in your life, and neither has anyone you grew up with in that part of the world. For 27 years, Europeans have had to fly to other continents to see the moon fully block the sun. This year, it comes to them. Let's walk through the day exactly how it will unfold, starting before the sun even comes up. Before sunrise on August 12th, 6 planets will be visible spread out across the sky at the same time: Jupiter, Mercury, Mars, Uranus, Saturn, and Neptune. Now, before you picture 6 perfect dots lined up in a row like beads on a string, let's kill that image right now, because that is not what a planetary alignment actually looks like. It is a wide arc, stretching from close to the horizon up into the sky. Mars and Saturn will be the easiest to spot with just your eyes. Jupiter will be bright but sitting low near the horizon. Mercury will barely peek above the skyline right before sunrise, and it is famously one of the hardest planets to catch, so hard that plenty of professional astronomers have never actually seen it with their own eyes. Uranus and Neptune are going to need binoculars or a small telescope. They are simply too faint and too far for the naked eye. If you want the best view, you need an open eastern horizon, and you need to be looking about 30 to 60 minutes before your local sunrise. In London, that window is roughly 4:54 to 5:03 in the morning. In Berlin, around 4:56 to 5:04. In New York, 5:18 to 5:34. In Toronto, 5:33 to 5:47. If you miss the exact morning, do not panic. This configuration is not a blink and you'll miss it event. The planets will still be worth watching a day or two before and after August 12th, so you can use those mornings as a dress rehearsal. Here is a small but important detail almost nobody mentions. If you're at mid-northern latitudes, cities like Madrid, New York, or Tokyo, you're in the sweet spot. The sky is still dark enough to see the fainter planets, but the low ones like Mercury have had enough time to climb above the horizon. If you're much further south, in places like São Paulo or Sydney, your window is shorter and the low planets might already be washed out by morning twilight before they're high enough to see. Location matters more than people realize. It also helps to actually know what you're looking at, rather than just aiming your phone at a random patch of sky and hoping. Mars will have a distinct reddish-orange tint, easy to pick out once you know to look for it. Saturn will look like a steady, pale gold point of light, noticeably calmer than a twinkling star. Jupiter will simply be the brightest thing near the horizon, hard to miss once it clears the buildings or trees around you. And here's a trick worth knowing if you want to actually resolve Uranus or Neptune through binoculars. Stars twinkle because their light is a single point being distorted by our atmosphere. Planets generally don't twinkle the same way because they're close enough to appear as tiny disks rather than pinpoints, so their light averages out and looks steadier. If something in your binoculars looks like a small, steady, faint blue-green dot instead of a sparkling point, there's a good chance you've actually found Neptune or Uranus, not just another star in the background. Now let's get to the main event, the one everything else in this video is building toward, the total solar eclipse. Before we get into the mechanics, it's worth sitting with just how differently people used to experience this exact moment. For most of human history, a total solar eclipse looked like the sky was dying in the middle of the day. Ancient Chinese astronomers described it as a dragon devouring the sun, and court astronomers whose job it was to predict eclipses were reportedly executed if they failed to warn the emperor in time. In parts of the ancient world, people would bang pots and pans together during an eclipse, convinced the noise would scare off whatever creature was swallowing the sun. The Vikings blamed wolves chasing the sun and moon across the sky. None of it was irrational, given what they knew. Imagine living your entire life watching the sun rise and set with total predictability. And then one day, without warning, in the middle of the afternoon, it starts disappearing. We have the advantage of knowing exactly why this happens, down to the second, centuries in advance. They didn't. And honestly, understanding the mechanism doesn't make it any less unsettling to actually stand underneath one. So here is what is actually happening on a purely physical level, so you understand why this looks the way it does. The moon is about 400 times smaller than the sun, but it also happens to be about 400 times closer to us. That ratio is so close to perfect that from Earth's surface, the moon and the sun appear to be almost exactly the same size in the sky. It is one of the strangest coincidences in the entire solar system, and it is the only reason total solar eclipses look the way they do, with the moon fitting almost perfectly over the sun's disk instead of covering too much or too little. And this will not last forever, by the way. The moon is slowly drifting away from Earth, a few centimeters every year, and in roughly 1.2 billion years, it will finally be too far away to ever fully cover the sun again. So in the grand timeline of the universe, we are living in the narrow window where this spectacle is even possible at all. On August 12, 2026, the moon's shadow will race across the surface of the Earth along a narrow path, roughly 180 miles wide, sweeping across the far Arctic edge of Russia, over Greenland, across Iceland, and finally down into northern Spain, the Balearic Islands, and a small sliver of northeastern Portugal. If you are standing anywhere inside that path, and only inside that path, the sky will darken dramatically, the temperature will drop, and for a brief window measured in minutes, sometimes just over a minute, you will be able to look directly at the sun with your naked eyes and see its outer atmosphere, the corona, glowing like a ring of silver fire around a perfect black circle where the sun used to be. Here is a detail that makes Spain's experience genuinely unique among modern eclipses. Because totality happens late in the day there, the sun will be hanging low near the western horizon when the moon fully covers it. That creates what photographers are already calling a golden hour eclipse, or a sunset eclipse, something most eclipse chasers almost never get to see. It could be one of the most visually dramatic eclipses in years. But it comes with a real catch. If you're in Spain and you don't have a completely clear, open view toward the west, a hill, a building, even a line of trees could block your view of the entire event. This is the single most common mistake people make with this specific eclipse. You can be technically standing inside the path of totality and still see absolutely nothing if your horizon isn't clear. Let's talk timing, because this part matters enormously. Across the entire planet, The total phase of the eclipse begins at 1658 GMT and ends at 1834 GMT. But do not confuse that with how long any one person gets to see it. The moon's shadow is moving across the Earth at incredible speed, so each individual location only experiences totality for a very short window as that shadow passes directly overhead. In Saranel, on the island of Mallorca, totality lasts 1 minute and 36 seconds, starting at 8:30 and 56 seconds in the evening, local time. In Reykjavik, Iceland, totality lasts about 1 minute, starting around 5:48 in the evening GMT. If you're planning to travel for this, you need the exact local time for your specific spot, not just the general window, because being 5 minutes off means you photograph a partial eclipse instead of the real thing. Now, where should you actually go if you want to see this in person? Spain is shaping up to be the most realistic option for most travelers, and it also has better historical odds of clear skies than the Arctic locations. Zaragoza in northern Spain has an estimated 86% historical chance of a clear view based on past cloud cover data. Burgos and León are sitting around 80%. Compare that to Reykjavik in Iceland, where the historical odds of clear skies drop to somewhere between 25 and 35%, because Icelandic weather in August is notoriously unpredictable. Greenland offers what might be the wildest, most dramatic scenery of any viewing location on Earth. Arctic landscapes, dramatic light, a true expedition feeling, but it is remote, it is expensive, and getting there is a serious undertaking, not a weekend trip. And if you are not in the path of totality at all, do not write this off. Across most of Europe, parts of North America, and northwestern Africa, you will still see a partial solar eclipse, and in plenty of those places, more than 90% of the sun will be covered by the moon. That is genuinely striking to witness, even without full totality. But here's a fact that trips people up constantly. 99% coverage is not the same experience as totality. Even with just 1% of the sun's surface still exposed, it is still far too bright to look at directly. The sky will not go properly dark, and you will never see the corona. That thin sliver of sunlight is roughly 10,000 times brighter than the full moon. So if you are in a partial eclipse zone, you need certified eclipse glasses for the entire event, every single phase, no exceptions, and you never remove them unless you are standing inside the path of full totality during the brief seconds when the sun is 100% covered. There's also a physical experience to totality that photos never quite capture. And it's worth knowing what to expect if you're lucky enough to be standing in the path. In the minutes before totality, the light around you starts to look wrong in a way that's hard to describe until you've seen it. Flatter, grayer, almost like a filter has been placed over the entire world. Shadows sharpen strangely. Temperatures can drop by several degrees within minutes as the sun's warmth is cut off. Birds often go quiet, and some animals genuinely behave as though night has fallen, because as far as their internal clocks are concerned, it has. Then, in the final seconds before totality, thin wavy bands of light and shadow, called shadow bands, sometimes ripple across the ground, an effect caused by turbulence in our atmosphere bending the last sliver of sunlight. And then totality hits. The sky goes to a deep twilight blue. Bright stars and planets pop into view in the middle of the day, and where the sun used to be, there's just a black disk wrapped in a pale, wispy ring of light. People who have seen multiple total eclipses consistently describe this moment as more emotional than they expected. Some cry, some go completely silent, some cheer. It tends to hit differently than every photo you've seen prepared you for. One more thing about Spain and Iceland worth knowing. This isn't just special for the world, it's historically special for these specific places. Reykjavik hasn't seen a total solar eclipse since June of 1433. The next one after this won't arrive until the year 2245. Let that sink in for a second. Somebody living in Iceland today has a chance to witness something that the last generation to see it experienced during the century before Columbus sailed to the Americas, and the next generation to see it won't be born for over 200 years. Alright, the sun sets, the eclipse is over. And if you thought the day was done delivering, you would be wrong, because the night sky still has one more act, and honestly, it might end up being the most memorable part of the entire day for most people watching from home. Once darkness falls on August 12th, the Perseid meteor shower reaches its peak. The Perseids happen every year in mid-August, when Earth plows through a trail of dust and debris left behind by Comet Swift-Tuttle, a giant chunk of ice and rock that swings through the inner solar system roughly once every 133 years. Those tiny dust particles, most of them smaller than a grain of sand, slam into our atmosphere at more than 100,000 miles per hour, and burn up in bright streaks we call shooting stars. The Perseids are famous for producing not just a high number of meteors, but some genuinely bright fireballs too, the kind that light up the whole sky for a split second. Here is what makes 2026 different from a normal Perseid year, and it is a bigger deal than most people realize. The peak of the Perseids this year falls almost exactly on a new moon. That means there will be no moonlight at all washing out the sky. In a typical year, a bright moon can drown out the fainter meteors, cutting what you actually see by more than half. Not this year. Under a genuinely dark sky, far from city lights, the Perseids can produce up to roughly 100 meteors an hour at their peak. And here's the number that should really grab your attention. The next time the Perseid peak lines up this perfectly with a new moon is not next year or in 5 years, it is 2045. This is close to the best possible viewing conditions this meteor shower will offer for the next 2 decades. It's also worth knowing where this dust trail actually comes from, because it makes the whole thing feel a lot less random. Comet Swift-Tuttle is a genuinely massive object, roughly 17 miles across, roughly twice the size of the object believed to have wiped out the dinosaurs. It last swung close to the Sun in 1992 and won't return again until the year 2126. Every time it passes through the inner solar system, it sheds a fresh trail of ice and dust along its orbit, and Earth cuts through the thickest part of that trail every August, which is exactly why the Perseids show up like clockwork every single year, rather than as a one-time event. You are, quite literally, watching Earth get pelted by the leftover debris of a comet that most of us will never live to see with our own eyes again. To actually see them, you want to get away from city lights. Give your eyes about 20 to 30 minutes to fully adjust to the darkness, and just look up. No telescope, no binoculars, no equipment needed at all, just your eyes and some patience. The radiant point, the spot in the sky the meteors appear to be streaking from, rises high enough for good viewing by around 10:30 at night, and conditions generally keep improving the later you stay out, right through until dawn. If you're near 60 degrees north or beyond, places like Iceland or Greenland, skip it. The sky simply doesn't get dark enough that far north in August for a good show. Mid-northern latitudes are your sweet spot. So let's put the whole day together, because if you're trying to plan around this, here's the actual sequence. Before dawn, you watch 6 planets rise across the eastern sky. During the day, or early evening, depending on your location, the moon takes a bite out of the sun, and if you're in the right narrow strip of Europe, blacks it out completely. And then, once night falls, the sky rewards you one more time with what could be one of the best meteor showers in a generation. Northern Spain is genuinely the strongest overall location if you want a shot at witnessing the entire trilogy in one 24-hour stretch. Decent odds of clear skies, direct access to totality, and solid Perseid viewing once the sky goes dark. Before you go outside on the 12th, here is your actual equipment checklist, and it is refreshingly short. You do not need a telescope for any of this. For the planets, your eyes alone will catch Mars, Saturn, Jupiter, and Mercury. Binoculars only help if you want to try spotting Uranus and Neptune. For the Perseids, you need absolutely nothing except dark skies and patience. The only non-negotiable item on this entire list is certified eclipse glasses, if you plan to look at the sun at any point before totality actually begins. Regular sunglasses, no matter how dark they look, do not block enough solar radiation, and using them can cause permanent eye damage without you even feeling it happen in the moment, because your retina has no pain receptors. And to circle back to where we started, no, gravity is not switching off. No, the planets aligning will not create some catastrophic gravitational pull on Earth. The combined gravitational influence of every other planet in the solar system on you, standing on Earth, is genuinely smaller than the pull of the furniture in the room around you. What is actually happening on August 12th needs zero exaggeration, zero conspiracy, and zero fake physics to be one of the most remarkable days for sky watching that most of us will ever witness in our lifetime. The real version is already more incredible than the fake one. If you want to actually see any of this yourself, the 2 things that matter more than anything else are timing and location, down to the minute and down to the exact spot you're standing in, especially for that eclipse. Get those 2 details wrong, and you could be standing in the path of totality and still see nothing but a partially blocked sun behind a rooftop. Now, this eclipse is not a one-time miracle never to be repeated. There is a reason total solar eclipses keep finding new corners of the planet to visit, and it comes down to a strange, slow dance between the moon, the earth, and the sun that repeats itself roughly every 18 years in a cycle ancient civilizations tracked long before they understood why it worked. If you want to know exactly where the next one is headed after this, and why eclipses trace out the specific paths they do across the globe, subscribe, because that is exactly what we're breaking down next.